Hold on, guys. Hold on, guys. Hold on. Check this out. Watch. Uh, doesn't that look different? That's because I got a pen. Look, I can write so easily now. Like, look, I can literally write, like, I don't know, like a circle. Before on a mouse, that's like hard, but like, I can draw a circle now. What if I don't do that? Alright, okay, let's just start in the video. Alright, it's about cross product, as you probably saw on the top here. But we're going to start off this cross product video by explaining that a cross product gives back a vector. So compared to the dot product, as before, the previous other product that you've seen, cross product gives back a scalar value or a real number. So that's just a little something different about cross product. It'll give you back a vector when you put in two vectors. Not that bad to understand, but I'm going to show you how you can solve for the cross product first. Let's say we have a vector called A with the values 2, 3, 4. I don't know. I'm just choosing random numbers. And we have the value B. I mean vector B with the values 5, 8, I don't know, 3 or something. And I'm just going to give you a formula for how to do this. You know what? Let's change this to U and V because that makes more sense. UV. So I'm just going to give you the formula, but I'm going to show you how to make the formula, like a pattern that the formula has after this. So you don't have to memorize the formula, especially if you don't get it on your formula sheet for your exams. UV, first thing is U2 times V3 minus, oh, forgot that, U3 times V2, comma, U3 V1 minus V3 U1, comma, what's the last one? U1 V2 minus V1 U2. So this is the formula for it. The 2 represents the I guess the second number. So 2's are just the j hat values of the vector, and 3's are the k hat value, and 1 is the I hat values. It's not that bad, but this formula actually has a pattern to it when you write down the numbers. I'm going to write down something called a matrix. Now, matrices, they're not that scary. And don't even think of this as a matrix, just think of this as like a table of sorts. So, hold up. I'm doing my eye clickers for my class. Okay. So, whenever you are solving for this is the I hat value. Let's actually write down the rest. This is the j hat. This is the k hat. What you can actually do is cross off the I hat value whenever you're solving the I hat value. And then you see how I wrote U2 times V3 here? Let's draw an arrow to represent that. You see how I wrote U3 to V2? It actually makes a cross with the leftover numbers that weren't x'd out. So that is an important thing to keep in mind. You can just make a table here actually and just make a cross, and you can get the first value for I hat. Now it's a little different for j, and it's the same for k as I. But I'll show you that as I'm solving this problem. We're just going to start it off by saying, let's say U hat cross V hat. Now keep in mind this is not multiplication. If it was U dot V, it would be completely different because that would be dot product. We're just going to make this equal to whatever we did here. We're going to make a cross. Always start off on the, okay, you see what you x'd out here? Go to the top right of what you x'd out. So the row you x'd out, start off on this one. Always start off on the right of the x. whenever you're making these crosses. So, u, v. The first starting number is u2 here, or the j value for u. So we're going to write down 3 times 4, because we're crossing. See the cross here? The arrow goes to 4. Subtracted by 4 times 8. 4 times 8, comma. Now we go into the next value. So I'll draw the table again for this. So for ease of understanding, visual representations always help. We're going to cross off the j value because we're solving for the j value. Now, remember what I said? We always start off on the right of the x. Well, this is what we're doing here. We start off on this value to the top right. So we start off on this value to the top right of the x. Now we start off on the top right of this x as well. Draw the arrow to the other side and just make a cross. And this cross product is the same as the formula here. u3 times v1, this is u3, and this is v1. And then minus v3 times u1, this is v3 times u1, right? I mean, like, honestly, it doesn't matter. You can do u1 times v3 here. This is u1, this is v3. You can just switch the arrows around, doesn't matter. 2 times 4 and 4 times 2 are the same things. But we drew the cross here. 4 times 5 minus 2 times 4. 2 times 4. Let's draw the table again. I hat, j hat, and k hat. 2, 3, 4, 5, 8, 4. So we're going to solve for the k hat. So we're going to cross off the k hat. What we're actually going to do here is, there's nothing on the right here, but imagine you just, this is like a portal. This is like a portal. You just go through, start from the right. This is to the right of the x technically. Or I guess on the top left. Okay. So imagine just going through and the arrow comes out on this other side. Always start off on the right of the x. So we make a cross with whatever numbers we have left. We always multiply this cross first to the right of the x, to the top right of the x. 2 times 8 minus 5 times 3. And doesn't that look familiar? In this formula, u1 and v2 are multiplied together here. This is u1 and this is v2, and they are multiplied together. Minus v1 down here and u2. Right? This is the formula. You just make your crosses, go into the top right of the cross, and just make an x, and start off on the top right. Formula is not that hard, and I'll just finish this problem. Maybe you did this along with me, but I'll finish this problem so that you know that you did it right, if you did do it. And I'm going to be making a practice problems video for this, because cross product is one of those things that require a good bit of practice. So in my opinion, doing the problems rather than just knowing the steps will help you remember it better. It's not even memory at a certain point. It's just, you just know it, basically. So this is the answer for that, for this cross product. We're going to do another problem, and we're going to follow through it so you guys can see more of the pattern. The more I do, the more I show you, the more you realize, the more, or at least the better you can recognize the pattern. So let's erase this, and let's make up random new numbers. I don't know, like 10, 5, 2, I guess. Let's use a negative number this time. -1, 3, -6. So with negative numbers, it's the exact same process. Okay, so I'm going to draw my table, and this time I'm actually going to leave out the I hat and the parentheses. I'm just going to draw the numbers out. -1, 3, and -6. So we can do u hat cross v hat. No, not u hat. U vector is equal to. So instead of this formula, I'll just show you this cross method that I use that I don't need the formula for. But since we're solving for I hat first, right? We're going to cross off the I hat row, and we're going to go onto the top right of the x, which is this number here. Create a cross with the arrows. You can see the little x going on here, right? And we're just going to multiply the numbers that the arrows point to. 5 times 6 minus, 5 times negative 6 actually, minus 3 times 2, comma, draw out the numbers again, 5, 10, 2, negative 1, 3, negative 6. This is the I hat portion that we already solved for. So now we're solving for the j hat portion here of the vector. So we cross off the j, start on the top right here, and just create a cross. So we always start off on the top right. The first number is the top right. 2 times negative 1 minus 10 times negative 6, comma. Now we're solving for the k hat part. So, again, let's draw our numbers. Negative 3, negative 6. We're just x off the j hat part. Now, for the x off the k hat part. Now, this is kind of weird. Go to the top right, and then it's like imagine you're just going through onto the other side. So we start off the multiplication, this entire process, on the top right of the x. Make a cross here, 10 times 3, and 5 times negative 1. 10 times, not negative 3, minus 5 times negative 1. And this is our answer for cross product. So we'll just finish this entire thing. This is negative 30 minus 6, negative 2 minus plus 60 technically, because this is subtracting negative 60. That's plus 60. And 30 plus 5. This is equal to negative 36, comma, 58, and 35. So that is the answer. Whoa. Yo, I've guessed for like most of my eye clickers right now, and for some reason, I'm getting them all right. Okay. I'm just taking attendance for my chemistry class right now, even though I'm at home. Yo, is that a confession? I'm not gonna lie, that's a confession. But, don't go after me, school. Don't go after me. But I'll actually show you another formula for cross product, and I'll just leave this one up here. So you can just keep looking at it. Maybe you want to just memorize it rather than knowing the process behind how to make the formula. But what the? Wait, redo. Oh, there's a snipping tool. Okay, I'll make this smaller so we can fit it onto the top right. There you go. Okay, so another formula for the cross product, you can actually find the magnitude of a cross product with this formula here. So the magnitude of vector A times, and this is not dot product, this is times the magnitude of vector B times the sine of the angle between them. Now, most of the time you're going to be given some like diagram with the angles that these vectors make along the each axis. So I'll try to draw that. I'll try to draw that right now. I don't know if I'm the best artist for this. But let's say you have a vector here, and you're given the angle that it makes. So this is the components of the vector. This vector is like, imagine it's shooting towards you. This is the x, y, and z. And you're going to be given this angle here, like 45 degrees or something. And you're going to be given this angle that this vector makes with this right here. I don't know, some like 30 degrees. And you'll be able to figure out the angle between two vectors like that, especially if you're given another vector with more information, right? So you'll likely be able to, or like this. Yeah, this makes more sense. You'll likely be able to figure out some form of information from this between the angles between the two vectors, or the angles that it makes with the axes. But honestly, I'm just gonna give you the angle. This is just most likely a plug. Like, I'll just show you how to plug it in and you'll get the magnitude of the cross products between these two vectors. So let's say your magnitude for A was equal to 5, magnitude for B was equal to, I don't know, like 4. The angle between them was like 45. And these were given. It'd basically just be 5 times 4 times the sine of 45, which is equal to 20 times the square root of 2 over 2, which is equal to 10 square root of 2. So this is just another formula that you can use, and you're likely not going to be using this formula for cross product. You're going to be using this formula for, how do I say this? You're going to be using this formula to find the area of a parallelogram, and I'm actually going to cover that in the next lesson video, or the next materials video, but I'm going to have a practice problem video for cross product because this is one of the things that you need practice with. I swear I've said that before already, this video. I swear. But I'll explain how a parallelogram works with the cross product here. But you're likely just going to be using this form to calculate area of a triangle or parallelogram or something of that sort. But to go on with this vector video, I'm going to show you what the cross product actually gives you. Because a lot of the times you're going to get word problems that are very incomprehensible if you don't know what the cross product actually gives you. I'll show you a visual representation of what cross product actually gives you inside of Desmos. Desmos 3D. Shout out to Desmos 3D. Okay, so now that we are in Desmos 3D, I can actually show you what these vectors look like. But I swear my mouse is inverted right now. Okay, whatever. But basically a cross product, and let's turn this off. So let's say you have two vectors that look like this, right? I'm going to turn on the cross resultant vector for the cross product, and you're going to see that this is actually perpendicular to both of these vectors here. So they make a 90-degree angle. If you line it up properly, it makes a 90-degree angle here. If you line this up properly, it makes a 90-degree angle. So the cross product actually gives a vector in three-dimensional space that is perpendicular to both of the inputted vectors. And I'm just going to mess around with this. So let's just mess around like this with this like crazy. Like 1, I don't know, let's set this like 6 or something. Just make something like crazy. I don't know, 3, negative 4. Okay. So these are our new two trippy. Okay, here. These are our new two vectors. I'm going to turn on the resulting cross product vector. You can actually see that the green, if I can line it up properly, this green thing, if you can see this green vector is the resulting cross product vector. It actually makes a 90-degree angle with this red vector, and it also makes a 90-degree angle with this blue vector here. So that's basically what cross product gives you. So you're going to use this a lot for like planes of 2D planes and 3D for the normal force, if you've heard of that before, or if you've already learned of that. But basically, this vector will be perpendicular to both of these vectors. Let's try out just another example. I don't know. I'll change it to like -3, and this is like 7. Turn this off. Okay. So I'll turn on the cross product again. As you can see, this blue vector makes a 90-degree angle with this green vector, and the red vector makes a 90-degree angle with the green vector. Now, here's the thing about this. You may be wondering, I don't know, why can't the arrow just go the exact opposite direction, right? It can go the exact opposite direction. It can still make a 90-degree angle with both these vectors. Well, you're going to basic physics conventions, or basic just math conventions in general. They use something called the right-hand rule. There's been plenty of videos of it online. Very hard to understand when you're just watching someone on a video. You probably need someone in person to teach you. But what the right-hand rule does is just tell you the direction of the vector, the cross product. So, I mean, like, honestly, it doesn't matter which way you point it. But for your exams, you likely want to follow the right-hand rule, which is basic convention. I'm going to switch around the values inside of this cross product. Before it is V1 cross V2. Now it's just going the opposite direction, right? It just depends on the order in which you put the cross product. And you'll be able to figure out the direction that this resultant cross product vector goes via the right-hand rule. So that's it for today's video. If you have any questions, put it down in the comment section.